Okay, this is 8.2. This is part 2, okay? And this will be pretty short. This shouldn't be very long. What we're going to do is we're going to talk about half-lives. Okay? So half-lives, basically we're talking about y equals a and b, the multiplier is 1/2 here to the x, okay? So that's a half-life function, okay? Right there, okay? Where we don't know a. A is our initial amount. Hopefully they'll tell us that in the problem. And then X is basically how many half-lives happen in our particular problem. Okay, so that's our setting. All right. So in this guy right here, we need to kind of go through here and underline everything we need in the problem. Technetium, I hope I said that right, 99M has a half-life of 6 hours. Okay, the 99 has no relevance in the problem. Okay, 6 hours is the half-life. That's important. How much remains from a 50 milligram supply? So what did I start with? That's pretty important. After 25 hours. How long was I looking at it with my little lab coat? All right. Okay, so relate here. It says, so it's telling us how to set up this thing here. The amount of technetium-99 is an exponential function of the number of half-lives. The initial amount is 50 milligrams. The decay factor is 1/2. Okay, that's what we already said that. So 1/2 life. Okay, what's 1/2 life mean? 1/2 life is the amount of time it takes the technetium to get cut in half. That is 6 hours. We have that in our problem. All right, so I think we've pretty clearly defined everything except y equals the number of technetium, x equals the number of hours elapsed. So now the number of half-lives is going to be x, the hours we watch, over the number of hours it takes for 1/2 life, which in this case is 6. The number of hours we watch is on top. The number of hours for the half-life is on the bottom. Okay, so we go ahead and write that out. We plug this into the box here, x over 6, where x is the number of half-lives that we plug in there. This line right here, we're gonna eliminate this. I don't. We have that stuff already in there. Okay. Now, what are we gonna substitute for x right here? X is the number of hours we watched. How many hours did we watch? We watched for 25 hours. Okay? So now it makes sense that this would be 25 over 6. Okay? Well, again, does it make sense? If I put my lab coat on for 25 hours and every 6 hours that got chopped in half, I would expect it to get chopped 4 times. So if I had 50 milligrams, so let's just do a little estimate over here. I had 50 milligrams. After 1/2 life, after 6 hours, I would have 25 milligrams. After 2 half-lives, I would have 12.5 milligrams, right? After 3, I would have 6.25. And after 4, was that 3 and 3.125 or something? Half of 6.25 after 4 half-lives. And I know 25 divided by 6 is just a little bit more than 4. So I'm expecting my answer when I plug it in my calculator to be a little bit less than 3.125 milligrams. So you can always, on a test or quiz, you can always check your answers this way quickly and easily. All right? So now, how do we put that into our calculator? Well, let's take a look. Okay. Be just a second to open this up. Sorry about that. Okay. Okay, so let's see. So we want to plug in this equation right here. And I'm always, so I tend to, if I want to make it for sure that I get it right, I'm going to start with the exponential. So I'm going to go 0.5 for 1/2, caret to the, and then parentheses, 25 divided by 6. Okay, get that number. Multiply by 50, and that's how much we have left. We have 2.78. Okay, so approximately 2.78. Okay, all right. So let's go ahead and basically we're going to try this. We're going to do the quick check. If you jump down past the example 3 there, we're going to do the quick check together. Okay, so let's go ahead and look at that. Um, Arsenic 74, again, the 74 doesn't mean anything. The half-life of 17.5 means something. 90 milligrams sample to start, that means something. How much is remaining after 6 days? So if I only watched it for 6 days, well, it better be quite a bit left because I know half-life is going to be, if it got chopped in half, it would be 45 milligrams. So it's got to be somewhere between 45 and 90, probably closer to 90, right? All right, so our setup, here's the original equation, a b to the x, and let's plug in y equals, what was my initial amount? As always in the a spot, I had 90 milligrams of stuff. What's my decay factor? Well, it's a half-life, so that number is 1/2 when we're talking half-life problems. Now, numerator, denominator. Denominator is always how long it takes for one half-life. Numerator will be how long did I watch it? How long was I in the lab coat? 6 days. Okay? Now we just plug this into our calculator. Not going to show that again. I think you can go ahead and do that properly. 1/2 to the 6 divided by 17.5 multiplied by 90, and you get right around 71 milligram. We're very close to that number. All right? All right, just to make sure that we have this, let's look at this one last time. If I had 70 days, life is good. Y equals AB to the X. And why is life good? Because Y equals 90. 1/2. Okay? And 70 divided by 17.5, well, that's going to be just 4. So basically 4 half-lives. So you could do this manually, or we could do this in a calculator, and you'd get 5, either way, 5.625 milligrams of stuff, of arsenic 74, whatever that is left over. Okay? So that's it for going ahead and getting your half-life and all that. So that's all taken care of. Tomorrow we'll talk about compound interest. Hope you're having a great day, and we will talk to you soon.